Hello, this is Mr. Wynn, and this will be the Chapter 5 test review. Remember, you do not have to write these down, but all these questions will be on your tests. You should study them. Now, if you do fail the test and you have to retest, you must write these down. So first, use synthetic division for that. Well, just a basic one. Remember, x minus 2 is our factor. That means our root is positive 2. The degree of our polynomial is 2. Add 1 to that for 3. There should be 3 terms. So x squared is 1, x to the first is negative 4, and x to the 0 power has 7. There's 3 numbers. So for synthetic, drop down the first number, multiply the number in the box, that's 2, add negative 2, multiply, get negative 4, bring down, that is 3. Alright, so basically if we're plugging in 2, we get 3 as a remainder, but that's our answer. Just be careful of any zeros. If a term is missing, put a 0 in the correct spot. Maybe the x squared term is missing, or maybe the x cubed term is missing, or the constant number term is missing. Factor this. Well, those are nice perfect cubes and sum. So remember, take the cube root of both of them. Cube root of that. Cube root of that. Cube root of 27 is 3. Cube root of m cubed is m. Cube root of 64 is 4. Put those into our formula. So 2 parentheses, a small one and a big one. Write our 2 numbers, our terms. Alright, the first one is a squared. So 3m times 3m is 9m squared. Multiply the 2, 3m times 4 is 12m. And then do b squared. 4 times 4 is 16. SOAP for the signs. So same as the problem, opposite of the problem, always plus. That's our answer. Find the value of p of negative 3. If p of x equals 4 minus x, well, that means plug in negative 3 where x is. So 4 minus negative 3 in parentheses. You put it in the calculator, but that's really 4 plus 3, which is 7. Just plug in negative 3 for x. Find p of 8a. If that's the equation, well, same idea as last problem. So wherever x is, put 8a there. So 8a in parentheses squared minus 8a plus 7. Well, 8a squared is 64a squared minus 8a, because there's nothing to do with that parentheses, and then plus 7. So that's it. Just keep plugging. Do not mess up on the exponents. Take the exponents first. State the number of real zeros for the function whose graph is on the right. So asking how many x-intercepts do we see? Well, I see 0. So 0 real zeros or roots. And now there are imaginary ones. Since there's, let's see, 2 minimums, 1 maximum, there's 3 extrema. The degree should be 4. There should be 4 roots. All 4 of them are imaginary in this case. But there's 0 real ones. Use the graph on the right. Find where, determine the values of x between which there is a root. It's a cutoff. Alright, so, well, I see the real root right here. That is between this, negative 2, and between this, that is negative 1. So my answer is x between negative 2 and negative 1. Alright, now I don't know what that is. Maybe negative 1.2, negative 1.1, but between those 2 numbers. Alright, find the x-coordinate where there's a relative minimum. Well, minimum is the bottom of a u. So right here is the minimum. The x part is 2. So x equals 2 there. Alright, that point might be 2, 3. The value of the minimum would be 3, but they want the x-coordinate. Not even 3. Maybe 2.5. Let's get that right. So maybe the value of the minimum is 2.5. Alright, solve this. Alright, solving. Well, that exponent's way too high. I can't use any formulas. Well, you could turn to quadratic, but let's focus on doing the synthetic to depress it until we get a quadratic, and then do quadratic formula. So this is basically 5/6 or 5/7 or 5/8. So let's set it up. I'm going to do synthetic. The degree is 4. There should be 5 terms. I only see 3 of them, so it's missing 2 zeros. So x4 is 1. x3 is missing, so there's a 0 there. x2 is negative 13. x1 is missing, so there's a 0 there. And x0 is 36. Alright, remember, I don't know what that number in the box is. And technically this is a guess, but we're not going to guess. We'll be smart and use the calculator. So graph it in the calculator. X to the 4th power minus 13x squared plus 36. Let's see what roots we can find. There's 1, there's 2, there's 3, there's 4. Ooh, wow, all 4. Okay, well, if it's all 4, let's check. So you can use trace. Click trace and type in what you think it is. I think there's a root at -3. I think the last one. So I'm trying -3 and enter. There's one there. I think there's one at -2 as well. -2, enter. There's one there, good. I think there's one at +2 as well. Trace 2, enter, good. And even 3. Alright, so I know there's -3, -2, +2, +3. So I write this up here. The roots are -3, -2, +2, +3. Right, let me make sure. -2, -3, +2, good. Alright, now remember there's 4 roots here. I found all 4, so this one was actually too easy that I need to do the work for. But on your test, you will not have 4 whole number roots, and some might be imaginary. So let's do this the correct way. You plug in one of those roots you found. I'll plug in the -3. Alright, if I plug in -3, I drop this first one. I multiply that by -3. Add them. Multiply by -3. Add them. Multiply by -3. Add them. Multiply by -3. And I get a 0 as a remainder. Remember, that remainder must be 0 if that's a root. So my 4th degree polynomial turns into this cubic. I'm going to x to the 3rd minus 3x squared minus 4x plus 12. Now again, that's exponent is 3. I can't use a subformula here, so I have to do synthetic again to depress it. So if the degree is 3, there should be 4 terms. I see all 4 of them. 1, -3, -4, 12. In the box, I'll pick something else. We already did -3, so let's try -2. When I do synthetic here, drop the first one, multiply the -2, add those for -5, multiply the -2, get +10, add them to get 6, multiply -2, add them to get 0, so that's good. So now we're at x squared minus 5x plus 6. And that remainder is 0 because it's a root. So now we have a quadratic. We should do quadratic formula in case we get imaginary roots or fraction decimals. So a is 1, b is -5, c is 6. Plug it in. So opposite of b, plus or minus square roots. B squared in parentheses. Now if you're the parentheses, you'll get it wrong. Minus 4 times a times c all over 2 times a. Do the discriminant. So what is that? Single number inside the square root sign. Well, 25 minus 24 is 1. That's nice. Alright, the value of the square root of the discriminant would be 1. Do the 2 cases. So 5 plus 1 over 2 and 5 minus 1 over 2. Well, 6 divided by 2 is 3. 4 divided by 2 is 2. So all my roots, I find 1, 2, 3, 4, which we knew were all 4. Alright, so put in the nice roots for synthetic division until you get a quadratic. Do quadratic formula. Alright, you have one factor, find the rest. Well, same thing as the last problem. We have, this time they're nice because it's a factor. Before we didn't have a factor, we just had to solve it. So if this is a factor, the roots would be the opposite, -2. Degree of the polynomial is 3, should be 4 terms. I see all 4, that's good. 1, 4, -11, -30. Do synthetic. Drop this, multiply, add, multiply, add, multiply. Good. Got a 0. So we have a quadratic, and the degree goes down by 1 each time. So plus 2x minus 15. Now that we're quadratic, we can go straight to quadratic formula. So a, b, c. A is 1, b is 2, c is -15. Plug it in. (b) plus or minus square roots b squared minus 4ac all over 2 times a. Alright, find the value of the discriminant. Let's see. 4 plus 60 is 64 over 2. Now actually take the square root of that discriminant, so negative 2 plus or minus 8 over 2. Do your two cases. Negative 2 plus 8 over 2. Negative 2 minus 8 over 2. So that's 6 over 2 is 3. And negative 10 over 2 is negative 5. Now make sure you answer the question. It said find the factors, not the roots. Remember, quadratic formula solves the problem, finds you the roots. For the factor, you got to put them in parentheses next to x. And when you do that, you got to change the sign. So that positive 3 turns to negative 3, and that negative 5 changes to positive 5. This is our answer. Because that's what I'd FOIL to get the x squared plus 2x minus 15 back. 10. Describe the number and type of roots of the equation 4x cubed plus 7 equals 0. Well, degree is 3. Means there are 3 roots. 3 total roots. Now we don't know how many real, how many imaginary. So to do that, I'm going to use a calculator. Let's graph this. 4x cubed plus 7. Graph it. Let's see how many x-intercepts we can find. There's 1 and only 1. We only see 1 x-intercept, meaning there's only 1 real one. 1 real root. Are there 3 total roots? Well, 3 minus 1 real. I mean, there's 2 imaginary roots. That's it. So of the 3, 1's real, 2 are imaginary. And remember, the imaginary come in pairs. There's going to be different signs for the I. All right, state the possible number of imaginary zeros for this. It's actually just like the last problem. So the degree, again, is 3. That means there are 3 roots. They just want to know how many are imaginary. So let's graph it. Negative 4x to the third power plus 2x squared minus 3x minus 4. Graph. Again, 1 real root. So 1 real. If there are 3, that means 2 are imaginary. So our answer is 2 imaginary roots. They only want the imaginaries. Right, there must be even number of imaginary roots. You cannot have 1 imaginary or 3 imaginary or 5. It must be even number. 12. Find all the rational zeros of this. Ooh, let's see. Basically, it's asking us to find all the roots. We're trying to solve it. So let's graph it first and see what it looks like. X cubed minus 12x minus 16. There should be 3 roots. I see 1, 2, 3. Ooh. All right. Let's trace. I think there's one at negative 2. There's one there. I think there's one at positive 4. There's one there. All right. So there are 3 roots because the degree is 3. I saw one at negative 2. I saw one at positive 4. Now the last one cannot be imaginary because that means there'd be 1 imaginary root. We call this when it hits the x-axis and it goes back down. We call it a double root because it bounced off the x-axis. It didn't go through it. So it's actually a double root at negative 2. So there's negative 2, negative 2, 4. Now let me show you the work to see how that happens. Let's do synthetic. Degree is 3, should be 4 terms. X squared is missing. So I do 1, 0, negative 12, negative 16. I plug in the one I see. Let's do 4. All right. Do synthetic. Drop this. Multiply. Add. Multiply. Add. Multiply. Add. All right. This lands with x squared plus 4x plus 4. Well, if I do quadratic formula, ABC. 1, 4, 4. Plug it in. I get negative b plus or minus square roots. B squared minus 4ac all over 2 times a. Negative 4 plus or minus square root 16 minus 16 is 0 over 2. That's negative 4 plus or minus 0 over 2. It's the same answer. Negative 4 over 2 is negative 2 and negative 2 if I do 2 cases. Alright, so that's why there's 3 roots.